Positively Perfect Problem Solving presents function notation. I'm going to start this learning target by reviewing evaluating equations. Evaluating, we talked about this word. This word means to plug into something. Let me get my pen here going. So evaluating means we're going to plug in and get a number. In this case, we have the equation 2t squared minus 5. When t equals -2. So what this means is we're going to replace that variable t, and when I replace a variable, I always make a skeleton with parentheses before I plug in. Then I take this -2 and I put it in for t. Now I'm going to simplify using PEMDAS, which is something we did a really long time ago. Remember, it's exponents first, so we're going to bring down the 2. -2 squared is +4. And then minus 5. 2 times 4 is 8. 8 minus 5 is 3. So I've evaluated this equation when t equals -2, and I've gotten an answer of 3. So that's evaluating something we did a while ago in the semester. So this is going to apply to something called function notation. I don't know if you've ever seen function notation before, so we're going to go ahead and take this a little bit slow so you guys kind of can see how this works. It's very strange. I'll point that out right away. So equations that represent functions are written in a very special way. We've talked about functions before, and there's something called function notation. We've talked about set notation, we've talked about inequality notation, we've talked about interval notation. This is another type of notation we use to describe equations. So normally the equations you've seen are like y equals 4x minus 1. That's slope-intercept form. You've seen it before. It's a very basic equation. Well, function notation is instead of saying y equals, we write it like this. Okay, now I know that looks very funny, so I'm going to kind of describe how this reads and what these things mean. When we say this out loud, it's really important to know how to speak this. F parentheses x reads as f of x, and then we say equals whatever the equation is. So I don't want to hear you saying f parentheses x. I want to hear you saying f of x. The f stands for function. Okay, so I'm saying function x, and I'm saying that the variable in function x is x. Okay, so it's the name of the function, f. We can name it other things. We could name it g, we can name it h, lots of different options for what we can name a function. The parts of the equation, so this guy, the x, is the input, what we put into it. And the y is the output, what we get out of it. And we talked about this last learning target about inputs and outputs. Okay, so we're going to start evaluating equations in this special notation. Before, like I just showed you, we evaluated equations without saying f of x or y equals or any of that. Going forward, we're going to start using this language. So function notation is especially useful for finding a value in the range that corresponds to a certain domain value. And in layman's terms, this means that we want to find an output if I give you an input. So here's an example. If f of x equals 4x minus 1, find f of -7. What this is saying is that this -7 is my input. And it's wanting me to plug -7 in for this and for this. So that if -7 equals x, what I'm going to do is I'm going to rewrite this to f of -7 equals 4 parentheses, oops, I forgot, -7 minus 1. So wherever I see that x value, so here's the -7, here's the x, and here's the x. All of these things are inputs, and notice I replaced both of these with that -7. So now I'm going to evaluate like normal, except I'm going to bring this f of -7 down, and I'm going to evaluate. So 4 times -7 is -28, and f of -7 then equals -29. Now the interesting part about this is that, and I'll use the yellow again, even though that's a little bit hard to see, I'm sorry. This -7 right here, let's change that to red. This -7 right here is my x value, and this guy right here is like my y value. Now, x and y is really important because basically we're saying that in this graph, like in this equation 4x minus 1, we actually have a point then at 2, 7. Oh, wait, I'm sorry, that's not correct. This shouldn't say 2, 7. Hold on, let me rewrite. I made a mistake. I'm going to cover this up in black. There actually exists a point then. So my x value is -7, and my y value is -29. That's what this is saying. X is -7, y is -29. So I have a point here at -7, -29 if I were to graph this equation 4x minus 1. So function notation helps us see that if we have an input of -7, we get an output of -29. It's all about these inputs and outputs, and function notation helps us do that. Okay. So moving forward, I want to do a little bit of practice with this when we have a lot of different equations we're working with, a lot of different functions. So here I've got 4 different functions. Okay. I've got a g here, I've got g, I've got f, I've got h, and I've got j. So g, f, h, and j are all different functions. They represent different graphs. So when I look at function notation, when I look at this g of 10, that means it's going to go here with g of x. So I'm actually going to use this equation right here. So if I know that 10 is my x value, when I rewrite this equation, I'm going to plug in for x. Instead of writing x, I'm going to write a 10. I'm going to keep going here and evaluate. This becomes -30 plus 1. That means that g of 10 equals -29. Ask you a lot to turn this then into a coordinate pair. So recognize that 10 is your x and -29 then is your y. Oops, sorry. With that said, I now have a coordinate pair at 10, -29. Okay, I want you to realize that the function notation represents coordinate pairs, my x and my y. The next equation now represents f. So I have an f of -6, so that goes with my f equation. So now instead of using the -3x plus 1, I'm actually going to use this x squared plus 7. I'm always going to use parentheses here before I plug in, especially because I'm plugging in a -6. When I start to simplify, I get -6 squared is a +36. So that means that f of -36 is going to give me a 43. So now I know that -6 is my x value, 43 is my y value, so the coordinate pair for this function is -6, 43. The next function I'm going to use is the h function. So the h function is here, and my h function, if I scroll up, is this one, 12 over x. So now I'm going to plug in -2 for x. So I'm going to get 12 over -2. That means h of -2 equals -6. Now, notice that in all these problems, I'm rewriting the function notation every time. Okay, I'd really like you to do that when you do your work as well. So that means that -2 is x and -6 is y. So I get a coordinate pair of -2, -6 for this function. The last one is j, and j goes with the equation here 2x plus 9. So now I'm going to plug in my 7 for 2x plus 9. J of 7 is going to equal 14 plus 9. So that means that j of 7 is going to equal 23. Now I know that I have a coordinate at 7, 7 is my x, 23 is a y, so I get 7, 23. So I think 4 examples is pretty good for what you're going to practice. So when you're doing your practice, please refer back to here. Notice how neat my work is. Notice how I've labeled things. A lot of you write down a bunch of math on your paper and I cannot follow it. And then when you go to do your mastery, you can't follow it either because your work is not neat. So please, please, please make sure your work is very clear and very neat. It's really important for this going forward. The next thing we use function notation for is tables. Okay, now remember, function notation is just describing x's and y's, or inputs and outputs. So in a table, we have inputs and outputs as well. So in this particular case, we're talking about boiling water at 212 degrees Fahrenheit is left in a room that's at 65 degrees Fahrenheit. So we're taking this boiling pot off the stove and we're setting it on the counter. And what's going to happen is it's going to start to cool off because it's no longer on the stove top. So temperature readings for this pot are taken every hour and are given in the table below. So we want to see how fast it's cooling down or how slow it's cooling down. In this scenario, the temperature T is a function of the number of hours. So if something is a function of, like this says function of, that means that T is my output. And this means that hours is my input. If I know that's the case, I can kind of pretend that H is X, and then I can also kind of pretend that T is Y. Now I don't want to use X's and Y's because this particular problem is using T and H, but this kind of helps me picture what I need to know. So the first equation says that T wants us to evaluate T of 2 and T of 6. I'm going to go ahead and erase X and Y so we do our function notation correctly. So I want T of 2. Now, T of 2 is our H. Okay, that's our input. So if that's my input, I want to look here for the number 2 because remember, H is my input. So here I see the number 2 and it goes with 104. So that means T of 2 is 104. Okay, now it wants me to find T of 6. So similar process. T of 6, I go find 6 here, and T of 6 is going to be 68. My input, if I wait 2 hours for it to cool, it's going to be 104 degrees. If I measure it 6 hours later, it's going to be 68 degrees. So that's what this means. B is a little bit more interesting, and it's worded a little strangely. This is saying that for what value of H is T of H equaling 76? So in this case, I don't know what H is. If I don't know what H is, but I do know what 76 is, I'm going to go now to the bottom table, find 76, and that goes with 4. So now I'm saying that after 4 hours, I get 76. So the value of H is going to be 4 for this particular question. So be really careful with A and B. They're asking two different things, and the language is very strange, but it's really always asking for inputs and outputs. The last question now says, between what 2 consecutive hours will T of H be 100? Now, oops, my pen. The word consecutive means in a row. So it's asking for 2 numbers that are in a row that will give me 100. So it could be between 1 and 2, 2 and 3, 3 and 4, 4 and 5. So where would 100 fall into place? So let's look at the first two, 212 and 141. 100 is not between those 2 numbers, so it can't be between 0 and 1. 141 and 104, 100's not between those 2 numbers because the lowest one's 104, so it doesn't get to 100. Now I look between 104 and 85, and there's where 100 would fall, because 100 is between 85 and 104. So to answer this between what 2 hours, that means I'm looking at hour 2 and hour 3. So my answer would then be between 2 and 3 hours, my temperature would at some point measure 100. Okay? Cool. The last thing we have to talk about in function notation is using graphs, evaluating graphs, because remember we talked about input and outputs being coordinate pairs. So coordinate pairs are really what we're trying to look for. Graphing is really the major part of finding inputs and outputs, because you want to find patterns, you want to see things going up and down, you want to see how the shape turns out in an equation. So when I look at these function notations, I'm going to remind myself that the number inside is my x value, or my input. So when I go to this graph, I'm going to go look, let me use a different color, it's much easier to see with colors. I'm going to make this be red. Okay, so that 1 is my x value. So I'm going to go to my graph, I'm going to find the number 1. There's the number 1 right there. And now I want to find my y value. What's my y value at 1? Well, I'm going to go up to 1, and there's my y value. And that coordinate is 1, 4. So if x is 1, then my y value is 4. So f of 1 equals 4, because remember, the input and output form a coordinate pair. So as long as that coordinate pair shows up on the graph and your function notation matches, then you're good to go with your solution. So that's f of 1. F of 5 is the same thing. All of these are the same thing, really. I just want to show a lot of examples. So f of 5, that's saying your x. We want to find my y. So I'm going to go find 5 on my x-axis. 1, 2, 3, 4, 5. And then I'm going to go find the graph where y is. And at that point, it's going to be -2. So I have a 5, -2 coordinate. So that means f of 5 is -2. And I want to write that coordinate down just to make sure I'm not crazy, and I do know that that coordinate falls on that graph. Now we want f of -3. -3 is my x. I'm looking for my y. So I'm going to go to 1, 2, 3. There's my -3, and make some dots down to where my y, my graph. Remember, this is your graph, this like crazy weird line. So we want to make sure the y matches that crazy weird line. So there's my point, and that's at the point -3, 1, 2, 3, 4. So now I know f of -3 is 4, and I've got a coordinate at -3, 4 on this graph. The last one is f of 0. So I'm going to now make a point at, what color haven't I used yet? Purple. Here's x is 0, and then dot, 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 dot. My y value is 2. So I have a coordinate at 0, 2. Okay. The key to this is remembering that in function notation, the inside number is your input and the number it equals is your output. Okay. Now it can be a little bit harder to go the other way. And by the other way, I mean that instead of giving you the input, they're going to give you the output. So what I mean by that is, in this particular example, it wants you to find x. So we don't know the input, but we do know the y value is 0. If the y value is 0, meaning I'm going to make a point, now instead of going up and down, I'm going to go left and right. So now I've got a point at -2, 0. Notice my 0 is in the y place, which makes sense because in the equation my 0 is in the y place. So I'm going to rewrite this, f of -2 equals 0, and I know that's true because I've got that coordinate here. So to answer the question, I could just say x equals -2 when y is 0. One last example, find x when f of x equals 2. So I'm going to go put 2 on my y-axis. So I know that this is my y. I don't know my x. But now I can see that if I draw a line down to here, I can tell that this has to be 0 because I don't have any other way to make this the sense of this coordinate. So I know that I have the coordinate at 0, 2. And that's what this coordinate is, 0, 2. So now I know that, sorry, let me rewrite this. Now I know that f of 0 equals 2, so I can say x equals 2 as my x value. Okay, and you can also write that coordinate just to double check. To me, that always helps. If I write the coordinate and then double check that it's on the graph, I know I've done it correctly. Okay, that's why I want you guys practicing writing these coordinates, understanding that the x is the input, y is the output, and that forms a coordinate on your graph. Okay, so that's all for function notation. Be very careful in your practice, like always. This is going to come up a lot going forward, so excelling at this is extremely important. Okay, good luck, guys, and please don't be afraid to ask questions.